Okay, welcome to the run through of what an interface control document actually looks like. In here, we're going to dive into some really good examples of what it look like, what the sort of common format is, and why you might use it and how you might read it as well, actually. So it's a really useful tool for your integration, which we'll soon find out more about. Okay, diving into this interface control document, I've pulled one from the internet by NASA. I've spent ages trawling to find some good examples, which we're going to run through. So this one is produced by NASA, and it's actually the zero or limited gravity ICD for NASA, basically. So they have this C9 aircraft where they run reduced or zero G gravity aspects in order to essentially run, experiments for that. So in order to conduct this service, companies might want to be testing their equipment in zero or near zero G. So NASA have set this up to essentially provide that service. So they've also produced an ICD for the aircraft in order to cater for how their equipment might interface with the aircraft. So you can see here, it kind of just introduces more about the system, what their system is, what their service looks like. Talks about the aircraft layout, floor layout, so straight away you can see if your experiment would fit within the space envelope, how it may be loaded through the cargo door. Then actually look here, so we're starting to talk about floor, hardware, attachment and so on. So actually we can determine how we might anchor or restrain our floor attachment. Really useful here, we can talk about straps with certain widths, lengths and fixed lengths and so on, as well as a bunch of different stuff. So that's kind of the restraints. Here's what I'm actually looking for: electrical power and interface. So actually if we wanted to power our experiment, then actually we have some really useful stuff that essentially will be able to tell us what sort of power we can get. So we know that we can get 28 volts direct current at 50 amps. And then we have these different AC supplies. We've got 115 volt AC, 208 single phase. Oh, we've got 3 phase as well as 5. And so we know that the aircraft's electrical power is distributed via 5 power distribution panels. These panels are located, etc., etc. So actually straight away, we know that if we wanted our experiment to have a certain power output, then NASA can give us that power via this document. This ICD is telling us that that can be achieved, type thing, and all the different powers. And then, of course, we need to know, okay, well, we know we can get the power, and so we have power type and power output, but now we need to know what the connector looks like. And so we are given these connectors as well. So that's the interface for this. So when we talk about integration, right? So when we're integrating our kit into this piece of equipment, we need to understand these interfaces and how they integrate together in order to successfully run our experiment or run the mission that we intend on doing. And so this interface control document actually just runs you through all the key aspects of that. So we've got gas, lighting, it covers everything in the aircraft actually that you might need in order to conduct that experiment. Ground facilities, there's a bunch of different stuff. And it's really useful, right? So actually, if you're producing a product, then you might produce these for internal interfaces as well as external interface. This is an external interface document. So it's an ICD for external interfaces for external systems. The internal interfaces look the same, probably a lot less information. You could have it all on one page. If it's just a power interface, you literally need just a small aspect of this to kind of make it doable. So that's an example of like an industry standard NASA one, that is quite good. Now I found something actually really cool, which was the Falcon Rocket's SpaceX user guide. So similar sort of context, slightly newer and kind of new modern age type thinking. In this, essentially the user guide, it talks all about the vehicle, the performance, the environment, the flight environment for load, vibration, acoustics, shock, and so on. And then it talks about interfaces as well. So similar sort of context, SpaceX offer ride sharing to get stuff into orbit. So if you were to design a bit of kit that had to go into orbit, such as a satellite, then actually you need to interface with the Falcon rocket in some shape or form. So actually understanding and integrating your components onto that is really key. So we're going to quickly run through this just super quick to have a look at it, but it's really cool. Actually, it gives you a good introduction to Falcon 9 and Falcon Heavy. It talks about the reliability, which you're going to obviously care about, because if you put a bit of kit on there and it blows up, then that's going to be really important. Architecture and design talks about pricing. Couldn't help myself. If you want to put something in orbit, it's 67 million quid. What else? Vehicles, talks about the different types of vehicles. What else? Talks about the structure, propulsion. It's really cool, right? They're actually telling people about their system and talking about the reliability of their system in order to, you know, have confidence and build confidence in the fact that actually your stuff might not blow up, or it might blow up. Injection orbits, so different types of orbits that can be offered. Yeah, really cool. Where's the environment stuff? Okay, so this is a little bit related to design. So if we were actually having to design kit that was going to go into an orbit, we want to know what environment it's going to go through. And actually it's going to go through a launch environment, which is like, you know, insane levels of noise and vibration. So actually we need to design our kit so that it can actually withstand that. So when we're looking at design, we need to be able to, you know, understand the environment it's going to be in. And this document is a really good example of, like, it's an interface document or it's a user guide, but it tells us that sort of interfaces and environments that we're gonna have to design for. So we're getting acceleration, which we have to understand. We're getting acoustics, so we can understand whether or not our kit can understand the acoustics, at what frequency, and so on. And then we can also have, I think vibration is in here. So we can determine whether or not, right, okay, so we got random vibration, we're having the different frequencies, which is pretty cool. Random vibration, as you can see, there's a lot of stuff in here, right? So actually half your time as an engineer is looking for the stuff you actually need, which I'm sure you're aware of: lightning protection, heating, compatibility, verification. Interesting. So, you know, it talks about actually, you know, the verification that will occur when your product gets integrated, actually whether or not they will conduct verification on that, or because they don't want your stuff failing either. Okay, interfaces, this is what I was looking for. Right, so here we have mechanical interfaces, so it talks about the interfaces of mechanics. So it's got payload adapters and separation systems. So it talks about bolted interfaces. It also talks about different sizes of stuff that you might have. It can have a clamp band. You can also have fairings. So you might have to put your stuff in fairings. Electrical interfaces. You know, here they're talking about during the mission integration process. Actually, NASA, you should have actually be better and just provide some generic stuff that actually people can design against SpaceX. SpaceX on payload. Okay, so they're saying, you know, you can get some 37 pin or 61 pin electrical connectors that can do some electrical stuff. And look here, they do mission integration process. So they also are integrating using ICDs. You get the gist. Anyway, so this is the really cool document for NASA. If you want to put a rocket into space, it's going to cost you 67. NASA keeps saying NASA, it's SpaceX. 67 million quid. But these are just some examples of an ICD, and this is, you can see it's really useful when it comes to the integration process, because you want to understand how stuff comes together. So whether you're integrating components, they'll have an ICD. Whether you're integrating subsystems, they should also have an ICD. And then if you're integrating systems onto larger systems or smaller systems, they will also have an ICD. So ICDs are imperative when it comes to integration. In the next one, we're going to dive into how you can create your own ICD and go from there. We'll see you there.